Okay, students, we're going to continue with Unit 5, and we're moving into Lesson 18. In Lesson 17, we found out what would happen if we either doubled or tripled the amount of one unit in a rectangular prism. And we found that the same effect would happen on the volume. So if we doubled one of the units, either the length, the height, or the width, we ended up doubling the volume. Today, we're going to look at what's going to happen if we play with more than one side. So let's take a look at the second part of our lesson, a square base. And it says that Claire sketches a rectangular prism with a height of 11 and a square base and labels the edges of the base S. Well, let's do that just to see what she's got here. So we've got a rectangular prism. So here it is, and it's got a square base. So I try to do my best with a square base. And so she labeled this, the height is 11, and then the square base edges she labeled S. So there's one S side and there's one S side. So remember, a square base, these side lengths are the same, even though it doesn't look like it in my drawing. Then she asks Han what he thinks will happen to the volume of the rectangular prism if she triples S. So this S, she's going to multiply by 3, and this S, she's going to multiply by 3, because remember, these are equal. And Han says the volume will be 9 times bigger. Is he right? And explain or show your reasoning. Well, if she triples this by S and she triples this by S, triples this S and triples this S, 3 times 3 is 9. So it kind of looks like Han might be correct, but let's look at it mathematically. We know the volume of a rectangular prism equals length times width times height. So we know we already have a length, which is S, and we have a width, which is S, and we have a height, which is 11. Okay, so I'm just going to fill in what we do know. She wants to triple, so 3 times this S and 3 times this S, and then we multiply by 11. Well, what's happening here? She's actually multiplying by 3 2 different times, which is the same as multiplying S times 9, and then our height. So that is explaining that he is right. So is he right? Yes, we think he is. And there is our explanation. So now let's move on and talk about cones. This problem says that there are many cones with a height of 7 units. We're going to let R represent the radius and V represent the volume of all of these cones. And then write an equation that expresses the relationship between V and R. And they want us to use 3.14 as an approximation for pi. So the first thing we need to know is, what is the volume of a cone? The formula for the volume of a cone is V equals 1/3 the radius times, 1/3 times pi times the radius squared times the height. So that is our formula. Now let's fill in what we do know. We know we have 1/3. They want us to use 3.14 for pi. And we don't know the radius, so it's radius squared, but we do know the height is times 7. So if we multiply all of this out, 1/3 times 3.14 times 7, we are going to get 7.33. And again, this is where your calculators come in handy. 7.33 times our radius squared is the volume. So this is our equation. Number 2 says predict what will happen to the volume if you triple the radius. So it kind of looks like we're just tripling one element, the radius, right? So if we multiply the radius times 3, that triples it. That's simple enough. However, our radius is not just our radius. Radius squared equals radius times radius. So if we triple the radius, our radius squared is going to be 3 times r times 3 times r, which will really be 9r. So predict what will happen to the volume. I'm going to predict that the volume will be 9 times greater if we triple the radius. Now they want us to graph the equation. So that boxed equation there, V equals 7.33 r squared, is what we're going to graph. And I meant to label these before I turned my video on, but I didn't get to it. So let's do that real quick. I'm going to skip a line in between. 1, 2, 3. So while I'm doing this, you guys can label yours as well. And we'll get this all done here shortly. And then this y-axis, we're going to do by hundreds, 200, 400, 500. Just what you wanted to do is watch me do all of these numbers. I apologize for not having this labeled ahead of time. All right, so I've got them all labeled. And now I just need to start plugging in. This is the radius. This is the radius. And this over here is the volume. If I can write sideways on this. Oh, there we go. Okay, so I need to plug in numbers for the radius. So if the radius is 1, 1 squared is 1. 1 times 7.33 is 7.33. So with my radius 1, my volume is 7.33. So it's going to be almost touching 0 because these are 100 increments. I'm going to go ahead and label it 1, and the volume is 733. That's my coordinate point. If my radius is 2, I'm going to have 4. Radius 2 squared is 4. 4 times 7.33, and that's going to be 29.32. So I'm going to go to 2, and again, it's going to be almost a third, and I'll label it 29.32. If my radius is 3, 3 squared is 9. 9 times 7.33 is 65.97. So 3 goes to almost here, and we'll call that 65.97. And then I've got 4. 4 squared is 16. Up here, 16 times 7.33 is 117.28. So I'll go 4, and I'm doing just above 100. And it's 4, 117.28. And then if my radius is 5, 5 times 5 is 25. 25 times 7.33 is 183.25. So I'm going to go almost to 200. And this is going to be 5, 183.25. I'm going to keep going because I think it's interesting to see what the graph does as the radius gets larger. 6 squared is 36. 36 times 7.33 is 263.88. So 6, and then we're going to be almost to 300, or I guess a little above 250. So it's 6 and 2, 6, 3.88. See how they're significantly going higher as the radius gets larger? And that's because we're squaring the radius. So 7 times 7 is 49. 49 times 7.33 is 359. So 7 is 359. So just above 350. So that's 359.17. And then 8 squared is 64. 64 times 7.33 is 469. So now we're above 400. 469. So I've got 8 and 469.12. I'm just going to do one more. 9 squared is 81. 81 times 7.33 is 593. So we're almost at 600. We're at 9 and 593.73. So if we connect this graph, this is what's going to be interesting. I'm going to use a different color here and see if I can sketch a line here, because it's not going to be a straight line. So we're going from here up a little bit further, and look what's happening. Our line is actually turning into a curve here. Because the radius is squared, the increase is going to be a lot more significant the larger the number of the radius is. So we're going to keep going, and you can see it is not a straight line. Well, it's not a straight line when I'm drawing them anyway, but this is kind of a curved line. And so they're asking us in number 4, what happens to the volume if you triple R? Well, if I have a radius of 1, I had a volume of 7.33, okay? If I tripled 1, that's my radius, I would have a radius of 3. And when I tripled the radius, the volume was 65.97. Remember in our prediction, we predicted that tripling the radius would increase the volume 9 times. Well, did it do that? And it did. And I'm going to show you how. So I've got 3 divided by 1 equals 3. So our radius, when it tripled, increased 3 times. Well, let's see what happens when I do 65.97 divided by 7.33. And if you do this on your calculators, you're going to get 9. So what happens to the volume if you triple R? The volume increases not by 9, but it increases 9 times. Okay, increasing by 9 means you would add 9. This is increasing 9 times. Just like the radius is increasing 3 times. And then it said, where do you see it in the graph? Well, we saw it between the radius of 1, the radius of 3. And then how do you see it algebraically? Well, we just saw it here algebraically. All right, so in our first lesson today, we learned that changing one dimension will change the radius by that same dimension. But now we're seeing that if we change more than one, we change 2 dimensions, we have to account for that in the radius as well. Or I'm sorry, in the volume as well. So let's move on to, we're at our summary already. So basically we're summing up the lesson to say that if we scale 2 dimensions of a prism by a factor of A, so that's like we multiply it by 2, then the volume, because we're doing 2 dimensions, the volume is going to be increased by A squared. So if I increase by 2, the volume is going to increase by 2 times 2, which would be 4. If I increase by 3, the volume is going to increase by 3 times 3, which is 9. And that's because we're scaling 2 dimensions. In the earlier lesson today, we only scaled 1 dimension, and that kept it the same with the volume. But because we're doing 2 dimensions, our volume is going to be affected by both of those dimensions being scaled. Okay, I hope you have a good rest of your day, and I will see you in class. Please write down any questions you have or feel free to email me. Thanks, everyone.